Okay, brilliant. So welcome to another episode of Spacelink's Hangouts. And we've had a request this week. So Emma, as I understand it, you're doing a recycling week this week?
Yes, next week we're doing Waste Week, and we're in charge of sort of leading school with it. So we've been doing a bit of research and generally finding out about waste. So we thought, let's look at not just waste on Earth, but let's look at waste in the universe.
Yeah, so that's a brilliant idea. So actually, space junk or space waste, or sometimes called space debris, which just means scattered rubbish, is actually quite a major problem. So I'm just going to share my screen with you, and you let me know if you can see it. And can you see my slides?
Yeah, we can see it.
Yeah. Okay, brilliant. So I'm just going to make that full screen. Okay, brilliant. Yeah, so obviously the idea of putting objects into space is quite a new thing. So we only started doing that in the 20th century. And last week we had our history of space exploration. So that sort of explained the timeline of sending things up from the 1950s onwards. And since then, it's just become more and more. So if you think of all the things that are using satellites, whether it's communication satellites for all our phones and TV, or whether it's science or military, or observing the Earth to do with agriculture and monitoring disasters, there's a lot of stuff up in space. So space debris is kind of the more formal term for it, meaning scattered pieces of rubbish. And can you guys see the little picture of Earth there with all those specks?
Yeah.
Yes, so here we've got this kind of major areas. You can kind of see there's a bit of a pattern all balled around the Earth. There's lots of little white spots, and then there's also sort of a ring. And these have got special names. So those that are balled all around the Earth are in low Earth orbit. And with the exception of the Apollo missions that went to the moon, any missions with humans on it have always been in low Earth orbit. So the International Space Station's there, the Mir space station was there, and anybody we sent up for sort of orbits around the Earth is there. And most satellites are there. Some go a little further out if they're going to the moon or to Mars, and obviously you had Voyager that went all the way out of the solar system. But the vast majority of all of our space missions and satellites are all centered around this low Earth orbit. So that's the real sort of danger zone, as it were. And then you've got geosynchronous Earth orbit. So geo meaning of the Earth, and then synchronous sort of at the same time. And that's they are a little further out, and they're sort of spinning at the same time. And you also have lots of missions that go there. But this isn't so bad. Things are a lot further apart out there, and then some things scatter really far away. And we're going to talk a little bit later about how to get things out of those orbits that are in the danger zone. So what kind of things end up as space junk? Can you guys throw out some ideas for me about what kind of things might end up as space junk?
Hey, Barnes.
Maybe some like bits of rocket engines and bits of rockets.
Okay, bits of rocket engines, rockets, George.
Maybe it's just well, yes, maybe rocks that are coming off planets, maybe floating around in space somewhere.
Okay, rocks from other planets. Lucy?
Bits of metal from satellites.
Metal from satellites, Lucas?
Food maybe because when the astronauts take food up, they might be scattered around.
Also sort of rubbish, maybe from the space station that they've thrown into space. Okay. Jacob?
Space station pieces.
Broken space station pieces, yeah.
And old space stations.
Yeah, that's like Jacob, old space stations. And last one, Dylan?
Maybe like things from the toilet because it goes into space. Like doing things.
Yeah, okay. Human waste, yeah. Okay, lots of ideas there.
Those are all fantastic answers. So yeah, all of those things are right. They end up as space junk. And somebody mentioned about rocks there. And although rocks don't qualify as space debris because they're natural occurrences, there are lots of rocks floating around in space. Fortunately, there aren't too many asteroids very close to Earth. There's a really a packed bit of the solar system just in between Mars and Jupiter called the asteroid belt, and that's full of asteroids. They're all quite far apart, but there are a lot of them. And so if you're in that area, that might be a bit more of a risk. But obviously space is very big, so things tend to be quite spread out, and you'd be quite unlucky to be flying a spacecraft and get hit by something in the asteroid belt. But all of your answers were really good about the old space station. Somebody mentioned bits of old rocket boosters. Those are a major cause of space junk. And so all of these things tend to cluster around the Earth because that's where we're using them. And when these missions reach the end of their life and aren't working anymore, a lot of them are just floating about. And as things get broken up where they bash into each other, and we're going to talk a little bit later about some of the major collisions, you do see smaller and smaller pieces. So there are a few big bits that are like old rocket boosters, but a lot of it gets broken down into really quite small pieces that we can't even monitor. And some of them are literally just little flakes of dust or specks of paint. And paint flakes are a major cause of space junk. And they don't seem like a paint flake would cause too much damage, but when they're going at really high speed, some of these things are traveling at sort of 10 kilometers per second, really, really fast. They end up damaging stuff. So here's a list of, I think you got most of all of these. So old satellites, spent rocket stages, fragments from collisions, paint flakes, and also the dust from the solid rocket motors ends up there too. So an organization called the United States Strategic Command, they tracked 17,852 objects in orbit above Earth. And that's just the amount that they've been able to track. So they have to be big enough and they have to have found them. But it's estimated there are over 170 million objects down to less than 1 centimeter size. So it's really starting to get quite busy up there. So some examples of space junk that I thought you might find interesting. The oldest is the Vanguard 1, which was launched by the USA in 1958. And that's currently the oldest thing floating around in space. And that's going to take about another 240 years before I think it's going to end up burning up in the Earth's atmosphere. So that's the oldest thing that's floating around up there. An astronaut called Ed White, on the first ever American spacewalk in 1965, he lost his glove. They don't have a picture of it, but that's floating around out there somewhere. We do have a picture of a thermal blanket that was lost on one of the space shuttle missions in 1998. So that got lost and floated away, and they managed to get a picture of it as it disappeared. Also, several cameras have been dropped, a spanner, a pair of pliers, a whole tool bag somebody lost, and even a toothbrush. So there's a toothbrush floating around in space around the Earth. The astronaut wasn't brushing their teeth. They were using it to clean something on the space station, and they sort of found that good old toothbrush, you know what it's like at home. Why invent a tool when you already have one that does the job? And they used to use toothbrushes to clean things, and somebody dropped one, so that floated away. And yeah, so the upper stages of rockets cause a huge amount of space debris, and so a lot of those are still intact. They haven't been broken up, but they're just floating around above the Earth. In the year 2000, one of the Chinese missions upper stages actually fell back to the Earth. And so although it is quite dangerous to have stuff floating about in space, it's also quite dangerous to have things fall back to the Earth. And so this is generally very well planned. And when they launch things from over in Cape Canaveral in America, they have a whole area underneath that doesn't have any people living in it, or cities and stuff, so that things will fall down somewhere safe, or very often they'll fall into the sea. So the space shuttle rocket fuel canisters that don't make it to space but fall back to Earth, they used to be recovered by people who would go out in boats and bring them in. And I don't know if you remember last time we spoke, we showed you the Elon Musk SpaceX system where the rocket fuel holders will actually land on Earth now and can be reused. But one of the other things that are not just accidents is actually has been testing of anti-satellite weapons. So the Americans and Soviets used to do this, and there's still some of this going on, where they send missiles to blow up old satellites to test them for military purposes. And so the largest ever source of space junk was in 2007, a Chinese anti-satellite missile test was carried out. And they used what they call a kinetic kill vehicle. So this hasn't got explosives in it. It's literally just a lump of metal that's fired. And that was going really fast at 8 kilometers per second. And they smashed it into a Chinese weather satellite to test to see if they could knock satellites out of space. And sure enough, it broke up into over 2,000 pieces that were golf ball sized, and estimated 150,000 other particles that were smaller than that. And that's going to remain orbiting in low Earth orbit for decades or centuries. And this picture you can see here, the red is showing you the path of all the debris from that one missile test. And also you can see there a white line just going around the globe. Can anybody guess what that white line might be the path of?
What do you think that white line is?
Yeah, the crater.
The equator?
Yeah.
Okay. What do you think, William?
Is it marking where the southern hemisphere and the north?
The southern and northern hemisphere, George?
Is it showing the routes that the missile went around the Earth before it smashed into that weather satellite and then kaboom?
Well, let's find out, shall we? Did you hear all of those ideas?
Pretty good guesses. You can see it's not quite the equator. It's a little off where the equator. That would be a little lower down, especially on that left-hand side of the picture, cutting across Africa and South America, South and Central America. This is actually the path of the International Space Station. So you can see that it's going to go right through this debris cloud very often. So, you know, we don't want to be smashing things up deliberately and leaving lots of debris, because the International Space Station has people on it, and that's going to be floating around and could possibly hit some of these chunks. So this is why we need to be really careful thinking of the future, because we're only going to be sending up more and more stuff to space, and we really don't want people in the International Space Station and also very expensive satellites going through these debris clouds. So what's the problem with having too much space junk? You obviously have risk of collision with operational spacecraft that can cause damage and cost a lot of money, could also knock out our sort of communication satellites and stuff. But one of the major problems is actually these little particles. They sandblast things. So if you've got optics or like lenses for your telescopes and cameras, solar panels, which often power these space missions, and of course your windows in the International Space Station, they essentially get sandblasted by stuff. And in this picture here, you can see a pit on the window where a window has been damaged by a particle hitting it. And also, with there being more and more stuff in space, there's this idea of something called the Kessler Syndrome that someone came up with, which is about a chain reaction starting, where each collision starts another collision and then another, and you just get a domino effect of things crashing into each other. So this could be really quite dangerous. And if you don't mind now, I'm just going to show you a short little movie clip from a movie, so that you can get an idea of what it might look like if you had one of these Kessler events. So I'm just going to play a little short movie clip. Has anybody seen the movie Gravity?
Yes.
Yes. So I'm going to show you a little clip from that, and this is the kind of thing that might happen.
If you write
oh, sorry, we've got an advert. Give me a moment.
You need to get Grammarly.
I write pretty much all day.
Here we go.
Immediate restart to Explorer.
Copy. Explorer, prep airlock.
Airlock engaged, ready to receive.
Houston, elaborate. Debris from the missile strike has caused a chain reaction, hitting other satellites and creating traveling faster than a high-speed bullet up to your altitude. Now copy. Copy all. Put a bow on it, Dr. Stone.
I can't. The board is still initializing.
I'm not going to ask you again.
1 second.
Not 1 second. Now. Shut it down. That's an order.
I'm sorry. Sorry, I'm done. Kowalski, initiate emergency disconnect from the Hubble.
All right, Reed, let's do this. Hold on your message. Houston, update? Well, we have a full-on chain reaction. It's been confirmed that it's the unintentional side effect of the Russians striking one of their own satellites.
They shut down their own satellite.
Right at disposal. Most likely a spy sat gone bad. Now shrapnel. Explorer ready to disengage HST.
Explorer, new data coming through.
What's the blowback, Houston?
It's not good. Most of our systems are gone. Free chain reaction is out of control, rapidly expanding. Multiple satellites are down and they keep on falling.
Find multiple satellites.
Most of them are gone. Telecommunication systems are dead. Expect a communications blackout at any moment.
Kowalski, visual of debris at 9 o'clock.
Half of North America just lost their Facebook.
Explorer, repeat. Expect a communications blackout at any moment.
Copy that, Houston.
Contact with debris. Debris is from a BSE sat. Repeat. I have.
Dr. Stone requesting faster transport.
We have to go. We have to go. Go. Go.
Houston, Explorer, copy. Explorer, Dr. Stone requesting faster transport to Bay Area. Explorer, do you copy?
Explorer, permission to retrieve Dr. Stone.
Your go, Houston. Houston, copy. We lost Houston.
Oh,
We lost Houston.
not too fast. We need to get the hell out of here. There's someone else there, man. Oh, wait.
Stop it.
Stand down.
Houston, this is Explorer, copy. Houston, this is Explorer, copy. Kowalski,
Explorer's been hit. Explorer, do you read? Explorer, Explorer. Astronaut structure. Dr. Stone, small structure. Dr. Stone, detach. You must detach. Don't detach that arm to carry you too far. Listen to my voice. You need to focus. I'm losing visual of you. In 3 seconds, I won't be able to track you. You need to detach. I can't see you anymore. Do it now. Houston, I've lost visual, Dr. Stone.
Right, so there we go. So that's quite a scary sort of idea of what might happen if you don't deal with space junk. Could you guys hear the sound okay on that clip?
Yeah.
Yeah, it's okay. Yeah.
Did you notice anything about the sound? Is there anything you guys noticed about the sound of the collisions?
Did you? We didn't really hear the collisions. It was the voices that we could hear.
Aha, so this is very deliberate in this film because in order to hear things, you need air, and there's no air in space. It's a vacuum. So Gravity is quite a realistic film scientifically in that there was obviously music and we could hear the astronauts talking in their microphones, but when you hear these collisions of things hitting each other, there's no sound. And that's true. In space, there is no sound. So you might, if you put a microphone onto a piece of metal, you might be able to pick up vibrations, but you wouldn't hear any of these collisions. So this is another reason why astronauts need to monitor things, and communications are very important so that they can warn people if these things are going to happen. But obviously you've got this kind of feedback loop that if communication satellites are getting destroyed, you can no longer tell people and warn people. And they do have facilities for emergency exit of the International Space Station, so they can get out of there if something like this happens, but we need to know in time to be able to warn the astronauts. So these are some of the things that people want to bear in mind of how we communicate if something like Kessler Syndrome happened. But obviously the thing that we really want to do is try and prevent that from happening. So yeah, I'm going to stay on this slide actually and ask you for some ideas. What kind of thing might we be able to do to minimize space junk?
Okay, so how could we minimize space junk? What could we do? Tia? You don't think that we can minimize space junk? Okay, let's come up with some ideas of what we could do to minimize it. Jacob?
You could use, instead of using the ones where they break up, they use the ones that just been invented.
So the
re-land and reuse.
Brilliant. So use the ones that we saw last time that can land back on Earth, that can be reused.
We can send some rocket that has an air thing that can pick up the metal, and it has like really big layers of metal, so it can't get broken if a big piece of metal hits it.
Okay, so think about the kind of materials that are being used that might not shatter. Okay. Yeah.
Well, you know how there's pickup trucks that pick up your rubbish? Well, there could be like a space one, so it could pick up all the space junk.
So a space pickup truck that cruises around in space picking up rubbish. And let's have one more from Gary.
I thought basically the same as Spanky, except it's a vacuum.
Like a vacuum, something that sucks them up rather than attracts them.
And then they can send it down to Earth.
That then goes back down to Earth, so like a massive Hoover in space. How interesting. Some interesting ideas there. Yeah,
so I mean, a lot of those, you know, they might sound like something out of a sci-fi movie, but these are exactly the kind of ideas that people are coming up with. So at the moment, there isn't any sort of laws or guidelines about this that are set in stone. The only guidelines are from the UN about what to do, but there isn't anything illegal about smashing up stuff and leaving all over space. But what you can do to minimize it is somebody mentioned about a Hoover going and like picking up space junk, like a pickup truck for rubbish. And here on the right is a kind of concept art for some mission plan that was going to do exactly that kind of thing. The problem with this kind of idea, and lots of countries have come forward and come up with these ideas for going and hoovering up the space junk, is that it's a very expensive mission. It's quite complicated, and it would be the same price as a lot of other space missions. So we're talking millions to hundreds of millions or even billions of pounds to do some of these missions. And, you know, how much space junk would they be able to pick up? You've got it all around the Earth. And so even if it cleared just one line of that, then it would be incredibly expensive and quite a difficult mission to design and execute to do that. But you know, you could focus on particular areas that were high risk, for example, the pathway of the International Space Station, and just try and clear that. So that's something a lot of space agencies and private companies are looking into now, to do exactly what you guys suggested of going and sweeping up space junk. Obviously, what we'd like to do is not leave the junk there in the first place, much like with Waste Week and ideas about recycling and environmental ideas here on Earth. You can design ideas to clean up after yourself, but the good thing to do would be not to make a mess in the first place. So there's various things you can do. Is you can try to, at the end of your satellite's mission, leave it enough fuel and in its design of its mission for it to get itself out of low Earth orbit or geostationary Earth orbit, and go off to a graveyard orbit. So this is something that the companies and space agencies plan now. So at the end of its life, it will have enough fuel to burn itself off to somewhere that's not dangerous and stay out there, out of our way. Also, there's something called passivation, which is to dispose of any unused fuel that's left inside rocket boosters or inside satellites, so that if anything does hit it, it might just be minor damage and just spin it, or maybe break a small piece off, but it won't explode because there's no fuel on it. Also, we can plan to make things re-enter Earth's atmosphere, so that at the end of its life, it will head downwards towards the atmosphere and it will burn up in Earth's atmosphere and just come down as tiny little particles on the Earth, rather than being chunks left all over space. And yeah, as you said, the cleanup missions are something that people are really focusing on, but trying to find a way to do this that's cost effective, because it would be as difficult a space mission as a lot of things. It would be very, very complicated to design and execute something like that. So yeah, that's pretty much all I have to say about space junk. But if you've got any questions you'd like to ask me about space junk or other things, then yeah, I'd be happy to hear them.
Okay, does anybody have a question about space junk and about waste and things that are in space? Yes, Barnes?
What's the maximum that a rocket can, like, put space junk out? So how much can a rocket, like, when its boosters go off, how much does it, like, how much rubbish comes off it?
So from one mission, from one rocket, how much debris would we expect?
Yeah, so that's a really interesting question. So obviously they design things to not have too much. So often it will just be one or two stages of a rocket. So it won't be much. It will just be one large chunk. As I said earlier, the maximum that's ever been produced at one time was from the missile test. So let's go back and see how much was that. So that was... yeah, 2,000 pieces of more than golf ball size, with estimated 150,000 smaller particles. So that's the most that's ever been made at one time, but that was from a mission test. If it's just an ordinary mission, there shouldn't be more than maybe 1, 2, or 3 larger pieces left behind.
Okay, yeah, Leona?
How many missions do you think that has got hit by space debris?
Oh, so how many space missions have been hit or had a problem because of space debris?
That's a really interesting question. I don't know the exact answer to that. I know that there have been several. There was a big one in 2009, another one in 2007. There have been several, and the one in 2009, that took out an active satellite. So I think that it's in the tens of how many have been and put out of action by it, but I couldn't tell you the exact number. But that's something you could definitely look up. But it's enough that it's a problem. It's enough that it's been causing quite a lot of sort of damage to satellites and also costing money. But I don't know the exact number that have been affected.
Yeah, Harrison?
How much missions would it take to get all of their space junk out of space?
Oh, to go and collect it up. If they, okay, so if they did manage to find a cost-effective way, how many missions do we think it would?
That's a really interesting question. So I think nobody knows exactly how many it would take, but depending on the design of what you do with the rubbish, because some of the designs were to return things to the space station. And so this would be a reusable mission that goes in and out and just constantly clears up, and would really be to kind of clear the path of your space station. So that might that might just keep running and running and get repaired on the space station itself. So that one mission could potentially do a lot, but in that sort of one pathway. To clear it all up, I think there's so much of it now that you probably need hundreds of missions to make any kind of impact on it. But it's something that at the moment seems like such an overwhelming problem. We don't have the technology, or at least the money, to develop the technology to do something to clear it all up.
Good question, Harrison. Has the ISS ever had sort of big impacts or problems? You showed us sort of the window there.
Yeah, nothing major. It's more just the windows is a real problem for damage because of this sandblasting and pits. You've also seen that on some of the space shuttles as well, on their windows. What space missions tend to do is they use something called a Whipple Shield, which is really good at deflecting high impact missiles. And so it's not only for space junk, it's also for meteorites and asteroids. And they're very, very effective at making sure that the energy from the impact just spreads out and doesn't damage something. But the problem with Whipple Shields is that they're not transparent. So for anything like solar panels and optics and windows, you can't use them. So the Whipple Shields prevent a lot of bad damage, but they can't do anything about the windows, unfortunately. And especially for human missions, you really need the windows so people can see outside.
Definitely. The view is a big part of it, isn't it?
Yeah.
Leona, have you got one last question? Anyone else got a question before Leona? Okay, Leona, do you want to ask the last question?
How many years have they been working on it, trying to get it out?
Oh, how many years have people been concerned about space junk?
That's a really good question. So the Kessler Syndrome that I talked about, that I showed you the scene from Gravity, where you get that chain reaction of collisions, that was come up with in the late 1970s. So since the 1970s, people have really been thinking about the catastrophic impact of space junk collisions. Before that, people were more worried about collisions of natural objects like the asteroids and satellites that someone mentioned at the beginning. So people have always been worried about collisions in space, but I think it's really since the 1970s, once the space program really took off, literally, and you had more and more things going up into space. Before that, in the 1950s and 60s, nobody ever envisioned, I think, that we would have so much stuff in space.
We've been really interested in the problem with plastics. And in our class has been interested to find out where plastics have turned up, because we had a hangout with Jamie in the Arctic, and he told us that they'd found microplastics right up in the Arctic, and they've even found, where was the carrier bag, Noah, that you were telling us about? The bottom of the Mariana Trench found. And so I was wondering how far out the space debris goes.
Oh, that's a really good question. So if you saw on that original slide I showed you at the beginning, there's some little dots really far out. So they're pretty far out. That's kind of the ideal thing you want to do, though, is to send these things as far out as possible. So I would say space junk, the furthest out is going to be Voyager. So that's still sort of beeping at us at the moment and sending back, but that's gone way out past Pluto. It's on the edge of our solar system in a region called the Kuiper Belt, and that's the furthest human-made object away from Earth, which is way out, really, really far away. It's taken years to get there, decades to get there. So that, when it's, I don't know if you can really call it a piece of space junk at the moment, because, you know, it's still pretty useful. But when it eventually dies, or if it gets hit by something and broken up, that will be the furthest away space junk.
Yeah. Wow.
But it's interesting you guys mentioned about plastics and stuff, because obviously a lot of space technology is used to monitor things on Earth, and you get big accumulations of rubbish, and you get these things in the ocean called gyres, which are kind of like almost like whirlpools. It's like a current of water, and things tend to collect there and spin around there. And you might have seen the sort of rubbish island. You've seen it on TV documentaries and stuff, and it's just a big collection of where the water currents bring all the rubbish together, and it sits there, and it's so big it's almost like a country in itself. It's like a huge island of rubbish. And obviously the problem with this is the impact on not only the water itself, but all the animals that live in there. And there's been a big problem with microplastics, which can be just ordinary plastics that get broken down small as they wear away, but also, you know, the little beads you get in shower gel and face wash. this is a real problem because they obviously go straight down the sink and then they go into the water, and then the fish think they're fish food and they eat them, and then bigger fish eat that fish, and bigger fish eats that fish, and it just goes up the food chain, and you just get a lot of plastics inside animals. And very often they'll find animals who've got plastic bottles and old toothbrushes and just all of our rubbish that's ending up in the ocean, and it's a real problem for ocean pollution.
Yeah, we're concerned about. I wonder what. Sorry. When I'm it's coming back again. But I wonder whether you were saying it's not illegal at the moment. You have rubbish in space. I wonder whether. Could you hear that?
Say that again, Emma. I didn't catch that.
I wonder whether there's laws in the future.
Yeah, I think there definitely will, because the thing is about space, it's a little bit of a wild west, you know. It's nobody really owns it. You're not allowed to own parts of the moon or Mars or anything like that. So there's actually a treaty that says nobody can own it, which is similar to Antarctica as well, that no one country or company can own pieces of it. So because there's no one country or government or industry in charge of it, it becomes a little bit of a wild west, and people can really do whatever they want up there. There's no one stopping people doing it. And this is also a problem with what they call planetary protection, because there's a whole field of study called planetary protection to make sure that we don't cause damage or contaminate the surface of other planets, especially places like Mars where we might be looking for life. And we don't want somebody going there and, like, you know, spreading bacteria around everywhere. And there's quite strict limits by NASA on where their rover can go so that it doesn't maybe bring any bacteria it's brought from Earth and contaminate Mars. But there's no law on it. And so this is the problem. If, you know, someone like Elon Musk says, I want to send people to Mars. Well, what about contaminating that area? What about any space junk that you might start leaving around Mars or things like that? And it's just, there's no one law to oversee it. So I think now as space travel and the real possibility of living on other planets and just the amount of things we're sending up into the sky, I think that you'll probably see in the next 10 to 15 years more of a focus on this, because it hasn't really been taken that seriously by some people. But you are seeing lots of money put into the development of these ideas for space junk collecting missions, and I think that they will start to bring in laws, because it's just going to get too busy there. It's the same problem you have on Earth as overpopulation, really, you know, just not managing resources properly and not clearing up after ourselves, which is why we have things like Waste Week and focus on recycling and environment, because we didn't think that it was ever going to be a problem, but it's become one.
Jacqueline, thank you so much.
No problem at all, and thank you for the special request. I'm sorry it wasn't a longer talk, but I really like that you guys sent us a special request for something that maybe we hadn't thought of. And if you have any other requests, or if you've got some theme going on that maybe doesn't seem like it's so much to do with space, it was really clever of you guys to come up with the idea that we could think about Waste Week in relation to the waste in space. So please do let me know if you've got any other special topics coming up and you want me to find a space related talk to go with it.
That's lovely. What do we say for now?
Thank you so much. It's, as always, a pleasure to speak to you, and thank you so much for your questions. And yeah, I hope to hear from you again soon, and we'll be seeing you to present another hangout.
Wonderful.
Thank you, Emma. Bye, everybody. See you.